All right. Hello, everyone. I hope I'm audible to all of you. Great, great. So, welcome back to this amazing platform of Tutee E-Learning. And today we are going to discuss the remaining part of the paper one. Okay. So, as of the last session that I have taken so far on the J Advanced previous year question, the question discussion of the 2025 paper, I have discussed the paper one. And in paper one, I discussed the single correct type questions and the multiple type questions. So in today's session, we're going to discuss the numerical type questions and I will try to wrap up the section D as well, which is the matrix type questions as well, right? So we're going to solve the numerical type, the section C and the matrix match type, which is the section D. So that is all what we're going to do today and let's get started. Okay, I hope I'm audible to all of you. Please give me a thumbs up if we can start or not. All right, so that's being said, pretty much let's get started. All right, so let's start off with the first question from the section third. So before we start again, I would like to make sure that you know the rules of the questions. That is, this particular section will consist of 6 questions, and the answer to these questions is a numerical values. And for each questions, enter the correct numerical values and answer using your mouse and on the on-screen virtual numeric keypad. And if the numeric value has more than 2 decimal places, just round it off or truncate. Okay, just round it off to 2 decimal places, and that's how you have to answer. Okay, so in these cases, you generally have a range of answers, but if it is directly coming up as an answer, then there is no chances of getting a range of answers. Okay, so if you do the correctly, you get +4, and if you get 0, in any other cases you get 0. So there is no disadvantage of getting a negative score. So that's being said, it's a very important um, part that you can start to solve because it doesn't have negative marking. Let's start with the first question. So the question is talking about, we have a set given over here. So if you look at over here, we have a set of all the relations on the given set. So let's say our given set is consisting of the elements A, B, C, D, E and F, right? And it is said that we have to find out all the relations from the set A such that I have to find the relations from set A to set A only. So the relations are consisting of, I should write it as relations are subsets of A cross A, right? That's very simple. And I have to make this relation as reflexive, symmetric. Okay, so I have to make this set as as a relation as reflexive as well as symmetric. And also it says that the relation R consists of just 10 elements. Okay, just consist of exactly 10 elements. So to find out how many elements, how many sets are basically there, and the R contains exactly 10 elements, be denoted by delta. So to find number of elements in delta, right? So let's try to go about with this question over here. As you can see that there are 6 elements in set A. 6 elements in set A. So that being said, if I need to make this set as a reflexive set, I have to choose any one of the following over here, and I can do it very simply by choosing one element of the 6C1. So that is simply given by 6C1. Now, if I need to make the set symmetric as well, we need 4 elements, right? So what I try to explain you is that we need 4 elements, but since R is symmetric, we will need a pair of alpha beta and gamma comma. So it's symmetric, so I just need alpha comma beta and as well as a pair of gamma comma beta, such that if I say that alpha comma beta belongs to the set A, or belongs to the relation, belongs to this relation over here, then and gamma comma beta also belongs to the relation, then you should have, for symmetricity, you should have beta comma alpha should also belong to the relation, and beta comma gamma should also belong to the relation, right? So we need to choose a pair alpha comma beta and beta comma gamma. So therefore we have to choose two things. Okay, so we have to choose in a pair. We have to choose out of the 6 element. We have to choose some pairs. So total pairs I can form out of it is basically given as 6C2. Total pairs I can make is given as 6C2. So if you look at the pairs, there are 15 pairs, right? So out of this, there will be total of 15 pairs. Now, out of these pairs, so there are 15 pairs, and out of this 15 pairs, we need just two pairs. Okay, we just need alpha comma beta and this gamma comma beta. So out of this 15, if we need two pairs, that can be simply given as 15C2. That is our number of elements that can be given in the set delta. Okay, so that being said, it's very simple. So we have to basically find number of that is, let the set of all relations R on the set such that it is reflexive and symmetric and it contains exactly 10 elements is denoted by delta. So the total number of elements in delta is simply given by 15C2, right? So the answer to this question is going to be 15C2, and if you solve it, it is going to be equal to 15 into 14 by 2, and that will give you 105. So the numeric value to this question is going to be just simply as 105. I hope this part is clear to all of you, right? So please let me know if this solution is clear or not. Please let me know if the solution is clear or not, right? Try to understand the solution. Okay, it's a very simple problem. We have to basically count the relations over here. Okay, and we just have to use the permutations and combinations things. Okay, right? Is this part clear to all of you? Does this make sense? Does this thing make sense? Yes, no? Does this make sense? Correct? No. Okay, so I hope this particular solution is clear to all of you. If it is clear, let's move to the next problem. Okay, so the next question, we have another question, another very interesting question from the geometry part. Okay, now if you look at the advanced paper this year, they actually gave you another kind of experiments as well as experiment with the geometry part as well. Okay, so it's a very simple problem. Let's try to read over the question, and it's a vector question. So it says that for any 2 points P and N in the xy plane, let Mn vector denotes the vector from M to N and O vector denotes the 0 vector. Let P, Q and R be 3 distinct points in xy plane, and let S be a point inside the triangle PQR such that SP vector plus 5 times of SQ vector plus 6 times of SR vector is equals to 0 vector. And it says that let E and F be the midpoints of the sides P and R and Q and R respectively. Then the value of length of this line segment EF by length of the line segment ES is how much? That's what you have to find it out. So let's try to figure out the first of all the triangle. Let's try to figure out the triangle first of all. So if we have the distress, the triangle, this is PQR triangle. So this is P, this is Q, and this is R, right? So this is a PQR triangle, and then it says that the E and F are the midpoints of PR, and F is the midpoint of QR, right? And it said that, so this is same and these are the same, and then it says that you have to find the length segment EF by ES, and ES is such a point, let's say this is such a point S, ES is such a point such that SP vector, so you have an SP vector and 5 times of SQ vector and 6 times of SR vector is equals to 0. So that's what is mentioned in the problem. Right, great. Now we have to find out how we can proceed with this question over here. So in order to start with this question, is always very easy if you can assume origin somewhere anywhere, and you can start with the assuming the position vector of point P, Q and R. Okay, since it is not given, let us try to assume it. Okay, let's try to assume p, q, and small p, small q, and small r as the position vector of the corresponding points. So if I just write down this sp vector over here, you can simply do it by p vector minus a small s vector, that is a position vector, plus 5 times of q vector minus s vector plus 6 times of r vector minus s vector, and that is equals to 0 vector, right? So if you try to figure this out, it's going to give you 5 p vector plus 5 times of q vector plus 6 times of r vector is equals to 12 times of s vector, right? Now if I ask you that what is ef vector or what is the modulus of ef vector, you can tell this the modulus of es vector, that is the length of the line segment es, so that is basically like s vector minus e vector and mod of it, and that can be given as, so s vector over here, because so e vector over here, the small e vector, the position vector, can be simply given out by the midpoint formula, and that can be given as p vector plus r vector by 2, right? So if I replace it over here, I'm going to get p vector plus r vector by 2 minus s vector and a mod of it. So if I say, and then I put the s thing over here, then this is going to turn out as 5 times of p vector minus 5 times of q vector divided by 12 and mod of that, because we are interested in finding the magnitude of it, right? Therefore from here, if I try to find out the ratio of these line segments, okay, the ratio of the line segments will be simply given as by ratio of this modulus, and that is given as, so ef will be simply given out as by ef will be simply given by p plus r by 2 minus it will be q vector plus r vector by 2 and mod of it divided by mod of p vector p vector minus q vector 5 times of it divided by 12 and mod of it. So if you just simplify this out, and you will find out this is going to be like p vector minus q vector divided by 2, and then it will be like 12 by 5 times of p vector minus q vector. Don't forget to put the mod over there. So that's going to be cancel out, and this is going to give you the result as 6 upon 5. This is going to give you the result as 6 upon 5, which is nothing but 1.2. 1.2. Therefore, the correct answer to this question is 1.20. 1.20. Right? So that's what's the answer for this particular problem. I hope this question is clear to all of you. It's a very straightforward, simple problem. You just do the algebra and all the things get cancelled out. I hope this makes sense to all of you. Yes, no? Does this thing make sense to all of you? Please let me know if this part is clear or not. Please do let me know if this part is clear or not. If something is not clear, I will try to repeat it again. Okay, you can do this. Okay, I can understand this part is not visible, so let me write it down. So this part, if you do this algebra and put it the s vector over here, it's going to come out as 5 times of p vector minus q vector, right, divided by 12 and mod of it. Okay, so that's what is written over there. BV base. Okay, that's nice, man. Yes, that's actually nice, right? DV boys, I think that's what you've written, right? Yes, DV boys, that's nice. Yes, correct, that is nice. Okay, for all of you who have solved this problem, I hope you must have got the answer as 1.2 when you were in the examination hall, right? If you have solved it correctly and you got the answer as 1.2, then you must have scored a +4 in it, okay? Right? I hope this part of the solution is clear to all of you. I hope this part of the solution is clear to all of you. Right? So let's move to the next problem then. No questions I see. So then let's move to the next problem. Okay. Now this is a very interesting problem that is from the portion of permutation and combination. Let's try to figure out how we can proceed with this question. It says that the set S S be the set of all the 7 digits numbers that can be formed using the digits 0, 1 and 2. So you have only 3 digits and to form a 7-digit number, right? So let's try to figure out what all sets I can classify the sets of numbers that can be present in the set S, right? It says this, for example, 2210222 is in S, but 0210222 is not in S. That's obvious because number starting with 0 is so if I starting with 0, then it won't be like a 7-digit number even if you put 7 digits. Okay, so that's being said is very simple thing. So I will try to classify the set S into 3 zones. It will consist of set A, set B and set C, where set A, the 0 will occur exactly twice, and in set B the 0 will occur exactly one. Okay, 0 will occur exactly one time. Okay, 0 will occur, sorry 1 will occur exactly twice. Okay, there is one provision for a number digit to be occurring twice. Let's say that 1 will occur twice. Okay, okay, and the C be the set of that 0 and 1 are exactly twice, right? Now why I'm doing it, it's very important to understand that how I'm going about doing this. Okay, because if I say that if I need to count for the number of elements or the number of numbers that can be present in the set which is having the following digits 0, 1 and 2, and then I have to figure it out, right? So if I just count on the number of elements in set A, it is going to be like 0 is occurring exactly twice, right? So there are 2 places where it has 0. So out of the 7 places, I will just leave the first place, and then out of the 6 places, I will have 2 places where I can put 0. And then the remaining places I can fill with 2 numbers, that is 2 to the power 5, right? Right? So that's being said, this is going to be equal to 480. Similarly, for let us count the number of elements in the set in the B part, where 1 will occur exactly twice. So for this case, we will have 2 different cases. Either 1 will occur at the extreme ends, so either 1 will occur here and here, or maybe it will occur out of this in the middle of these 5 places. Okay, so I just have to take the union of both. So if it occur at the leftmost place, okay, so in that case this can be given by 6c1 into 2 to the power 5, and if it is not in the leftmost place, then out of this any 2 places I can take, out of the 6 digits I can take any 2 places, and then I can permute with 2 to the power 4. So that being said, this will give the number of cases for B as 432, as 432. And similarly, for C, the 0 and the 1 will occur exactly twice. 0 and 1 will occur exactly twice, because you have to see, look at the question. Okay, if you read the question, it said that the number of elements in X in S such that at least one of the digits 0 and 1 exactly appear twice. Okay, so that's what cases I'm trying to look for, right? So I hope you don't have any questions. So therefore, if I look at the digits 0 and 1, they are exactly occurring twice. I cannot have zeros coming in the front digits, right? So what I have to do is that I have to first of all count in the all possible solutions minus the number of solutions where 0 zeros are coming at the 0 0 and 1 1 are coming at the beginning. So if I just able to reduce those numbers, so if I don't think of anything, then I just permute it. So it will be given by 7 factorial, by 3 factorial, by 2 factorial and by 2 factorial, minus those cases where it is not allowed. So that will be like minus 6 factorial divided by 6 factorial divided by, then we have 3 factorial by 2 factorial, right? That will give you all these cases for this C. Then the number of elements in C will be simply given out as 150. It will be simply given by 150 over here. I hope this is clear. So therefore, the total number of elements X such that the digits at least 1 or 0 exactly appear twice, that particular number of cases is going to be the sum of all these cases. And if you sum this up, 480 plus 432 plus 150, you're going to get the result as so. Okay, so yeah, I'm very sorry, I should forgot to mention this should be subtracted, right? Yes, because this should be subtracted. Okay, or I mean this is union and this is intersecting. Okay, so that's why. because you can understand at least one of the digits 0 and 1 appears exactly twice. Okay. So you have to remove those cases where the number of valid 7-digit numbers with zeros and 1 exactly appearing twice. Okay. So if I count that, now this will give you the correct result, and that is going to be 480 plus 432 minus 150, and that is going to give you the result as 780. That is going to give you the result as 780. I hope this part of the solution, sorry, 762, extremely sorry, 762. Okay, extremely sorry, 762 is going to be the correct result. I hope this is clear to all of you. I hope this result is clear to all of you. Please let me know if this result is clear or not. Yes, no, anything? Is this result clear to all of you? Right? That's also a very interesting problem. Just to break the problem into different sets. That we generally do in the questions of permutation and combinations. Okay. And if you any chance you have watched the videos, I have also taken some questions where I explained you the numbers that is possible by the digits, and where repetition is allowed and where a particular condition is not allowed. So I also broke those problems into different sets. Okay, so that this is appearing, this is appearing, this is not appearing, and then I counted for union and intersections. Okay, that's how we generally proceed. Okay, I hope this is clear to all of you. Please let me know this part is clear or not. Please let me know this part is clear or not. Right? So if this part is clear, let's move to the next problem. Let's try to move to the next problem. The next problem being said is a very interesting problem, and you just have to apply the results that you know. Okay. So here it is a question of limit, and if you look at the problem over there, you can figure out this is a question of 0 by 0 form. Okay. And generally students, whenever they see 0 by 0 form, they think about applying the L'Hopital rule. Right. So we're also going to do the same thing over here, and we are also going to use the L'Hopital rule over here. And if I use the L'Hopital rule, then this can be given as limit x tending towards 0 and differentiation of the numerator and the denominator. So the differentiation of numerator will be given as alpha by 2 1 by 1 minus x square, right? And then plus you will have this as beta times cos of x minus beta times x sine of x, right? And then whole divided by 3x square, right? And this result is given to us as equals to 2, right? So again, if I put 0, let's see what form it is becoming. So again, if I put 0, and then if alpha by 2, and if I put 0, so this part is going to be alpha by 2 plus beta, and the remaining thing is going to be 0 by 0 form. So if I have to make this 0 by 0 form, then alpha by 2 plus beta has to go to be equal to 0, has to go equal to 0, so as the 0 by 0 form to be satisfied. Otherwise it will be like finite number by 0 number which is not defined, and the limiting value is also finite, right? So I have to make this and adjustment such that this is basically becoming the finite answer, right? So therefore, having this result, again I will think of, and then if I have this result as 0 by 0 form, then again I will apply the L'Hopital rule. So if I again differentiate this and I put in this value, so this is alpha minus 2 times of 1 minus x square whole to the power minus 2 into minus of 2x plus, sorry, minus of beta sine x, and then minus beta sine x, and then we'll have minus beta x into cos x whole divided by 6x, and that is equals to 2, right? So again I see that this is basically again becoming a 0 by 0 form. So in order to make it a finite result, again we have to differentiate it. So that's what the statement of L'Hopital rule is. So again, if I differentiate it, and then in this case I will have the result as x into 0, it is alpha into minus of 2, and then we will have 1 minus x square, 1 x square whole to the power minus 3, and then multiplied with minus 2 to the power whole square plus alpha times 1 minus x square whole to the power minus 2 minus 2 beta cos x right? Minus 2 beta cos x minus beta cos x, and then we have plus beta x sin x. That's all, right? And then whole divided by 6, and this result should be equals to 2. So from here you will get one more equation. So if you put x equals 0, the result is alpha minus 2 beta minus beta by 6 equals to 2, and that will give you alpha minus 3 beta is equals to 12. So that's your second equation. So you have alpha, beta, and two equations, right? Two equations, two unknown, you can easily solve it. So that's the first equation, and this is our second equation. So if I just solve it, sorry, so if I solve it, I will get beta is equals to minus 12 upon 5, and once I have beta, our alpha is equals to, it should come out as 24 upon 5. So once you get beta and get alpha, so therefore you have alpha, you have beta, so alpha plus beta will come out as 12 upon 5. Okay, so alpha by beta will come over at 12 upon 5, and that is nothing but sorry 2.6. That's nothing but 2.4. So it will mention the answer as 2.40. It will write the answer as 2.40. I hope this part of the solution is clear to all of you, right? Is the solution clear to all of you? Is the solution clear to all of you? Please let me know if the solution is clear or not. This is a very straightforward problem, right? So you just keep on differentiating it, and unless and until you get a finite form, okay, not when you get a 0 by 0 form, right? So you have to go on differentiating it, and once you get a finite form, that will be equal to the value of the limit. From there you will get the values of the unknowns alpha and beta, and on solving you will basically get both your alphas and betas, right? So it's a very similar problem that you can see in the 2016 paper of JEE Advanced, and many papers. If you just go into the 11 paper, and if you look at any previous year paper like JEE Advanced, in some of the papers you will see, definitely notice, this kinds of problem has been asked in the previous year question as well. Okay, so it's not a kind of a new question, but I would say the different algebra. Okay, that's it. They're making you do different algebra. So it's a very simple problem and an easy problem. So again, a +4 for all of you. Okay, it's a very easy +4 for all of you. Is that part clear to all of you? Is this thing clear? Please let me know if this part is clear or not. I'll try to explain you it again if something is not clear, right? Please let me know if something is not clear. I will try to repeat it again. Okay, and if you're watching the session after the live class is over, you can always leave your wonderful doubts in the comment section after the live is over. Okay, so I will be very happy to answer your comments. Okay, so looking forward for that. All right, that's being said, great. Okay, great. So that's good to hear that you are able to understand these things, and things are clear, right? Exactly. So let's move to the next problem then. Let's move to the next problem, right? The next problem is again a very interesting problem, and if you look, it's a problem of sequence and series, right? So if you look at the problem over here, it says the R denotes a set of all real numbers, and we have a function which is going from real numbers to real numbers. It's a function such that it's always positive, and for all x belongs to R, f of x plus y is equals to f of x into f of y. Now, there's a functional equation involved as well, right? So, and then it says that let R real number a1, a2, and so on up to a50 be in arithmetic progressions, and you have to say that, you also said that such that f of a31 is equals to 64 times a of 25. And it's also mentioned about the summation of the numbers over here is given as something like this, and then you have to find out what is the value of this particular summation. Then what is the value of this particular summation? That is what you have to figure it out. So it's a very interesting problem, and whenever you see a functional equation like f of x plus y is equals to f of x into f of y, your general solution of the functional equation is generally equal to a to the power x. Okay, this is something that you must know. Okay, and if you don't know, you can just try to put it over here, and you will see this is basically this same thing. Okay, so this is something very simple, and I know every one of you know it, right? So therefore the function equation f of x is equals to a to the power x. Okay, now our only job is to basically find out what is that a over here, right? And it says that this a1, a2s and a50s are in arithmetic progression. So if I take on any a of r, it can be given a1 plus r minus 1 into d, right? Correct. And let's assume that d is the common difference. Okay, d is the common difference. Common difference of the AP. Okay, let's assume that d is the common difference of the AP over there, right? Now, if I just look at the summation, that is that is I going from 1 to 50, that is I going from 1 to 50, f of ai's that is given as 3 into 2 to the power 25 plus of 1, right? So if I do that, let's try to see. So therefore, this I can write as a to the power of ai's, which I can write as a1 plus I minus 1 times of d and summation of it, right? Which I can also write as, now a to the power a1 is should be a constant number, so it will come out. So a1 minus d will come out, and the summation will be like a to the power I times of d, where your I goes from 1 to 50, where your I goes from 1 to 50. And this particular summation, if I just find it out, is nothing but it's a geometric summation. Okay, it's a geometric progression, and this will come out as a to the power a1 minus of d, and this is going to come out as a to the power d, sorry, a to the power d multiplied with 1 minus a to the power 50d, sorry, a to the power 50d divided by 1 minus a to the power d. Okay, and that is given to us as 3 into 2 to the power 25, sorry, 25 plus of 1, right? So if I just go on doing with the algebra for the second condition as well, then I'm most probably going to get, so a to the power minus d, and this d is going to cancel out. So here you get one equation, and similarly you have one more condition, that is f of a31. Okay, that is a to the power a1 plus 30 times of d is equals to 64 times a to the power a1 plus 24 times of d, right? And from here you will get a to the power a1 and a1 get cancel out, and a to the power 6d is equals to 64, and therefore you will have a to the power d as equals to 2, because 64 is 2 to the power 6, and that's how you get a to the power d as 2. So if I just put over here a to the power d, and then I figure out what is a to the power a1, so if I just put it over there and then I solve it, I'll get the value of a to the power a1 as 3 upon 2 to the power 25 minus of 1, right? Therefore, our ultimate job is to find the summation of this. So this is going to be equals to, um, a to the power a1 into a to the power d whole to the power 5, and then we will have, because it's a geometric summation again, okay, it will be like summation of aids, okay, aids, and then multiplied with the constant part, that is a to the power a1 minus of d, right? Very simple. And the summation is going to I equals to 1 to 30, and then if I do that, it's going to be like a to the power a1 into a to the power d whole to the power 5 into a to the power d whole to the power 25 minus 1 divided by a to the power d minus 1, and we know all the values, and now then let's plug it into it, right? So if I just plug it into it, I'm going to get the result over here as 3 by 2 to the power 25 minus of 1 into 2 to the power 25 into 2 to the power 25 minus 1 divided by 1. So if I just simplify, and this can cancel out, and we're going to get the result as 3 into 32, and that is going to be equals to 96. That is going to be equals to 96. So therefore the numeric value that you're going to report as 96.00, 96.00, that is going to be the correct answer to the question. I hope this part of solution is clear to all of you. I hope this solution is clear to all of you. Okay, that's great. That's great. Nawab Sahi. Right, that's great. Okay, amazing, amazing. Um, this question was a simple question. Okay, and I know you all know these kinds of simple formulas. So just go and explore the questions of arithmetic progressions and geometric progression. That's what the question was. Okay, so again, it's a very straightforward problem and easy +4 for all of you. Easy +4 for all of you. Okay, so that's being said, let's move to the last question of the numerical type question, and it's a question where you are given a differential equations in y1, y2 and y3, and based on that you have to find out the value of limit. Again, it's a very simple problem, just you have to go on solving the algebra. Okay, so it's a very simple differential equation that I know that you all actually can do it. Okay, so if you just separate the variables, you can easily go about doing this integrals. Okay, if you just separate the variables, and you can do this integral, and this is going to come out as, so if you just do about this integral, the y1 is going to come out as e to the power 1 by 2 well x minus sine of 2x by 2 plus some constant c1. Similarly, and we have the value of y1 of 1 is equals to 5 for getting the constant, and therefore your constant value is going to come out as natural log of 5 minus 1 by 2 plus sine 2 radians by 4. Okay, so you have to just go on doing this algebra and these calculations, and similarly your y2 is going to look like, similarly you can also do the y2, which is also the variable several form, and the y2 is again going to look like, so it is going to look like e to the power 1 by 2 into x plus sine of 2x divided by 2 plus some c2. Okay, and you can find c2 as minus of ln 3 minus half minus sine 2 radians by 4. Okay, and similarly now if you look at y3, again you can do it by variable separable form, and then y3 will again look the very same. It is like e to the power minus of 1 by x square plus some constant c3. Okay, and you can solve this constant on your own, and you can find that the constant c3 from this value y3 of 1, this constant will turn out as 1 plus natural log of 3 minus natural log of 5. So you have all the values and all the constants, and now you are ready to plug in the values into the limit. Okay, so the limit, if you look at over here, it's just a simple problem. You just have to keep on solving the algebra, that's it. So limit is a right hand limit extending to 0 to find out limit of y1 of x into y2 of x into y3 of x, right? y1 of x, y2 of x and y3 of x plus of 2x divided by e to the power 3x into sine of x, e to the power 3x into sine of x, right? And then if you just calculate this limit, this is going to be e to the power minus of 1 upon x square, because when you multiply, the exponents goes on added, right? And then the common things got cancelled out, so it is e to the power minus 1 upon x square, right? Plus of 2x divided by e to the power 3x into sine of 2x. That's great, right? That's perfect. And then if you just go on solving this, you can easily do it on your own. Sorry, you will have sine x, okay, not sine of x, sorry. You will have sine x, so therefore if you divide it and then I multiply it, this goes to 1, because limit sine x by x for x tending towards 0, right? That goes to 1, and then if you just calculate this and you just solve it, and this will come out as equals to 0 plus 2 divided by 1, right? Perfect. Okay, so that is going to be equals to, so what I'm doing is that I'm cancelling out x, okay, from this, and then divided by x over here, right? So that's what I did, and then if you just do it, you're going to get the result as equals to 2. So therefore the numeric value of this particular problem is going to be simply as 2.00. Okay, so that's the numeric answer. I hope this particular solution is clear to all of you. I hope the solution is clear to all of you. Please do let me know if the solution is clear or not, right? I hope the solution is clear, and that's being said, we are pretty much done with the numerical type question that I actually planned to solve in this today's session, right? So in case you have any more questions, you can always put that in the live chat, or if the class is over, you can also put your questions in the comment section. Okay, I'll be very happy to help you out with your lovely comments. Okay, so with this, let's end our session over here, and thank you. Stay tuned for the upcoming session on paper 2, and we're going to soon come up live and solving the paper 2 as well. Okay, so with this, I thank you for your attention, and thanks.